Okay, perfect. Thank you so much for the introduction, Kasha, and thanks everybody for sticking around towards the end. I'm very excited to talk to you today about rapid prototyping for soft and stretchable electronics. So a little bit about me. I'm a product manager at Voltera. I have a background in nanotechnology, joined Voltera in 2014, have been a material scientist, a product engineer, electromechanical design engineer, and now I'm leading our entry into next generation electronics at Voltera. If you haven't heard of Voltera, in 2015, we created a circuit board printer that would help electronics engineers speed up their development time. We were inspired by how 3D printing could bring ideation to concept for mechanical design, and we really wanted to do the same thing for electronics, focusing on the PCB manufacturing process. However, shortly after we launched the product, over the next couple of years, we spoke to our users and found that they were really surprising us with what they were doing. So these weren't the electronics engineers, or some of them weren't the electronics engineers and product developers that we'd initially imagined using this. These were researchers and scientists at world-leading institutions who were really pushing the boundaries of what was possible with electronics. And from that, we learned a lot about what could be possible when you go beyond the green FR4 board and conductive materials that we were working with before and into this whole new space that many of you call flexible hybrid electronics. Now, the V1 had never been designed for this particular application set. So when we went back to a lot of these users and we asked them, what is it that you really need to help get you from where you are to where you want to go in your research, we identified quite a few common themes. So the first, of course, the reason why they started using our technology in the first place was that we use direct write digital printing. So you can load up a file, create a design, and then in a matter of minutes have a printed conductive pattern or otherwise functional pattern in a matter of minutes. The next thing they were asking for was the ability to work with a variety of screen printable inks. Digital printing has for a long time been the realm of inkjet materials, but screen printable inks give you so many options in terms of material categories and fillers and functionality. And finally, the benchtop form factor that would allow you to keep this in your lab, not have to book a ton of time for you to be able to get something done very quickly, potentially go through 5 iterations in the span of a day, rather than having to wait weeks or even months to get your first design tested. Now, over the past couple of years, we took this feedback, and I'm excited to say that sometime this year, in Q4 this year, we will be announcing our new product specifically for flexible, hybrid, stretchable electronics. So this will be coming in Q4. If you want to see us in person with our new product, you'll be able to see us actually at the next live TechBlick event in Eindhoven, and I look forward to seeing you there. However, let's give you a quick inside look at what this product will allow you to do. So this will allow you to create flexible electronics at your workbench. So if you want to create a flexible prototype, a flexible circuit on PET with silver inks, you can do that in a matter of minutes. It'll also allow you to create stretchable and soft devices, which is something that I know a lot of you are very interested in, and we're very excited to demonstrate also. You'll be able to do this just as quickly as you could have done with rigid or traditional electronics. And finally, people ask for materials freedom, and that's what we're going to be delivering. So if you want to be printing with silver inks, carbon inks, copper inks, this is really a tool that allows you to load up nearly any screen printable ink, calibrate it, and then you'll be able to print that in a matter of minutes. So I believe I'm going to try and rush through this, guys. Let me know if I'm running late, but let's go through the applications here. So to help you explore the possibilities of what's possible with desktop soft electronics prototyping, let's look at 3 case studies that we've prepared. Actually, our interns prepared over the past couple months. So we're going to start with a soft insole pressure sensor, so some custom electrodes that allow you to sense how someone's gait may be modified. We're going to look at a wearable pocket heater afterwards. It's integrated into fabrics. And finally, a thermoformed electric mug heater. So going from dynamic to static stretch to show you kind of what you can do there. So if we're doing the soft insole pressure sensor, you're just printing and curing on stretchable substrates, which, I mean, at this point, it seems fairly simple to us, but it's something that really lets you get to that point without having to do any kind of tooling. So for this example, we just used a thermoplastic polyurethane substrate and a stretchable conductive ink that we sourced from an ink manufacturer. You can ask us, we'll let you know which one. We took a flexible carbon sheet to cover that conductor, and then we iterated on a couple electrode patterns to get to a 5-zone sensing electrode. And as you increase the pressure, it decreases the resistance. You got a foot-shaped FSR, and you're good to go. For our next case study, we've got a wearable heater. We took that same concept of printing on stretchable electronics, and we integrated it into clothing. So after printing and curing, then you can heat laminate that device to denim. In this case, we use denim. You can use synthetic fabrics as well. We made it a battery-powered device. And because we were in Canada, it was winter, we wanted to consistently heat to 45 degrees Celsius, which we were able to do. Keeps your hands nice and toasty. And this was a really fun project for one of our interns to work on. Finally, we've got this Thermoformed Mug Heater, which is a single stretch application rather than a dynamic stretch application, but really helps you get those lightweight 3D electronics. So in this case, we started with a 3D printed mold that we put together on our form printer. We used an inexpensive desktop thermoformer called a Meiku, and then we took an in-mold conductive ink and printed on polycarbonate, thermoformed it with 50% strain in the maximum strain regions. And after this, connect it to some power, and you've got yourself a thermoformed mug heater. So this thing definitely will keep your drinks warm throughout the day. You'll be able to keep your coffee hot in the morning, and if you're a real slow drinker, you can get that at lunch as well. So that kind of wraps up our case studies portion. Hopefully I'm within the 5 minutes. If I'm not, I'm sorry, but if you want to see us in person, we will be at TechBlick Live on the 12th and 13th of October later this year with the product. We'll have everything there. You can come, you can see it, touch it, and you can talk to us about it. If you can't wait, you want to get in on that early access program, Jan Ganache, he's actually also in this event. You can talk to him anytime. He'll fill you in on the program. And if you have questions, you can, of course, talk to me. My email's right at the beginning there. But also, I'd encourage you to reach out to Jan. He's an expert in this area, and he'll be able to hold your hand through the whole process and show you what we can really do with our next generation products. So thank you very much for sticking around. This was a lot of fun, and hopefully you guys will have me back.
Thank you very much for the very nice presentation, and yeah, thank you for the sneak peek. You know, we can't wait to see the product.